Hello everyone. I'd like to talk about phones for a bit, if you'll let me. I have quite a bit of phone stuff, and I will not be talking about all of it today for what are probably obvious reasons. But the thing is, I do have a lot of phone stuff, and well, if you know me personally, which very few of you do, and if you know me personally, you might be surprised that I don't have more videos about this. I think I only actually have one video that just deals with phones directly. I've got another one about this horrible IP PBX that Microsoft made back in the 2000s, which I actually shot months ago, but it is so boring. It is such drudgery getting through it. It's like 2 hours long, and so much of it is just explaining basic concepts that I've not been able to get myself to finish editing and release it. And that's sort of the problem with telephony, is that it requires so much front-loaded information. You have to explain so much about it. And when you get all the way to the end, when you've explained everything, you want to know what it all does? Oh, dial tone. We can dial now. A ring. And now we're talking. And that's what phones do. And that's the only thing that phones do. And while there is a very vibrant hobby around telephones as a concept, they're mostly based on the infrastructure. The majority of phone nerds that I know, even the biggest phone nerds I know, don't actually like talking on the phone. And 95% of their interest ends as soon as a call is connected. Like, overwhelmingly, it's about the incredibly complicated machine behind the scenes that connects phone calls together. And that is fascinating, don't get me wrong. I was fascinated with it for years. You see, I grew up with phones, which is such a ridiculous thing to say, but what can I say? My dad worked for the phone company back in, oh geez, I know he's watching, he's gonna correct me, the 60s? I think the 60s, 70s? And then later on worked for one of the Baby Bells, I believe, after the phone company got split up. And so growing up, I would just get regaled, not infrequently, with explanations of how various bits of the system worked, so I had a pretty good idea. Listen, by age 10, I knew what tip and ring were. All right, it was a bleak existence. Then after that, I went and got a job. My first job was at a place we would now call an e-cycle store, but that concept didn't exist yet, so it was just a surplus store, which was sort of a California phenomenon, you know, places where you could buy like old discarded electronics from the enormous electronics industry down there. And I worked with people there who also had experience at the phone company, or at least, you know, were around back when phones were a bit more visceral to the average nerd. There's a lot of stuff out there about phreaking and about the hobby of knowing how telephones work. And it used to be an awful lot of people did it without any real insight into the system other than just picking up the phone and messing with it. And so I worked with some people who had that sort of background, and they told me more about it. And then I went and got a job at a phone company. I'm kind of cheating here. It was a voice over IP phone company, which is not really phones in a lot of ways that matter, but I worked with a lot of traditional telephone technology there because our job was largely replacing existing conventional phones. So a lot of customers couldn't rip out all their old stuff at once, or weren't planning to at all. Like, there's a lot of companies out there that bought like a PBX phone system back in like 1989, and they still like it, and they never want to get rid of it, but they want to pay less for their phone lines. So they get voice over IP service, and then they have us install a gadget like this. This is called an Adtran Total Access TA924. And this is literally a device that's meant to bridge between the old world of telephony and the new, or actually several old worlds. I don't want to get too deep into the lore here, because boy howdy is there a lot, but this thing actually speaks 4 different generations of telephone signals. It does plain old analog service, you know, the type of thing that this sort of phone uses, the type of thing that this sort of phone uses. It goes all the way back to the late 19th century. That comes out this hole here. I'll talk a little more about that later. These interfaces here are for T1, which was developed in the 70s. It was a first digital telephone format. It got used for a very, very long time before getting updated to a thing called ISDN, or PRI specifically, which is what these 2 ports are for. And then finally, the Ethernet interfaces are for voice over IP. And this thing is just a clearinghouse. It's a router that converts freely between all of those formats. And in fact, this company, Adtran, made a lot of devices that did that even more directly. Where's my, here we go, here's my Atlas. This guy here is more of well, I think it's more of a carrier grade version of the same thing. This speaks even more formats, and it's got interchangeable cards. So if you needed more analog or more digital or whatever, you could do that. So there's a whole galaxy of equipment for dealing with the old and turning it into the new, or turning different types of the old into the other types of the old. And I got asked to do everything under the sun. So I'm no expert, all right? There's a lot of people out there who know more than me, but I've done quite a bit, and I've seen quite a bit. And the problem is that nobody cares. Like, other than the people who are already phone nerds, who already have and do this stuff all the time anyway, who all know more than me, it's really hard to explain any of this stuff to, forgive me, normal people in a way that's the least bit engaging. Because when it comes down to it, this is what phones do. They let you talk on the phone. That's it. So for years, I've collected phone stuff. This is a very small portion of the stuff I have even now. I've got like 3 tubs of other phone miscellany sitting over there, but it's not very photogenic. And it's actually a very small portion of what I used to have. I used to collect PBXs, business phone systems. You plug them into the real phone network to get outside calls, but then you can build your own internal phone network with a whole bunch of phones plugged into it that you don't have to pay the phone company for directly. And they give you all sorts of extra features, call transfer and conferences and stuff like that. And eventually, the shine really started to wear off all this, so I started divesting myself of all that stuff. And then somehow I just ended up with it again. I'm just accumulating things once again. And it's gotten so bad, actually, that I have a PBX again. It's really miserable. I don't know how this keeps happening. This is an Avaya Lucent partner system, and it works with these really, really ugly phones. I mean, just look at this exhausting thing. You look at this and you're just like, wow, I don't want to go to that job tomorrow. I'm just going to stay in bed. It just keeps happening. I had a good reason for this, but still, I will never be free of phones, will I? It's by no means all bad, okay? Knowing stuff about phones is useful. It's allowed me to do videos about fax and modems and things like that. But just because I know what I know, it's really hard not to collect interesting things. And it gets a little frustrating because I feel like I have nowhere to squeeze these into a video anywhere. I have all this stuff that I've had for eons. I kept telling myself like, oh, well, if I need to explain such and such concept, I've got a prop. You know what? Every time that's come up in a video, I've been like, no, that's too involved. Let's not drag everyone down with me. But since I have all this stuff, and since it's winter, and every year by law and by tradition, apparently, I have a terrible time during the winter, I decided that, listen, I can talk about this stuff in my sleep, so that's what I'm going to do. I'm just going to tell you about some of my phone stuff, and then we'll break for lunch. So let's start with probably the most important thing in my whole collection, which I only actually got fairly recently. This is the Teltone TLS5 telephone line simulator, and it does exactly what it says on the tin. We've got 4 jacks up here, and each one of these shows up to a connected device as if it were a normal phone line coming from the phone company. And you saw exactly what that allows. You can make calls without needing a real phone line. If I wanted to spend like $120 a month, I could bring in 4 copper phone lines from the phone company to my office in order to plug in things like phones and fax machines and modems and test them. And there's advantages to doing that with a real phone line, which I'll touch on in a moment. But it's a huge pain in the ass, of course, because they would only be in this one location. They wouldn't be portable. I couldn't go test stuff at home, for instance. But also, yeah, you're paying a lot of money for that, which sucks. On the other hand, though, other approaches to getting a fake phone line that a lot of people use are not really adequate for my needs. What most people do who are just, forgive me, casuals about this, is they get a VoIP ATA. This is a device into which you plug 1 or more phones. This is a 2-port model, but I have them all the way up to 8 ports. And this too produces what looks like a fake phone line. It produces dial tone, and you get the 48-volt DC talk battery that's required for all phone lines to actually run the circuitry in the device. But when you place a call with it, it just turns it into IP packets and sends it off either to a PBX if you have one, or off to a cloud voice service provider. And theoretically that works fine, and a lot of people have no trouble messing around with old phones using devices like this. The trouble is they're not perfect, and they need to be. For many, many, many decades, a phone line was a very well-defined thing. I mean, the phone company had reams of documentation and specifications stating exactly how a phone line had to behave. And the reason is because they were delivering the same service to literally hundreds of millions of people. They needed it to be completely consistent so that all of the instruments, the phones that people were using, would work no matter where they were, so they wouldn't have to constantly be doing diagnostics to find out why one phone works here but not there. And then once people started buying phones not from the phone company, because they used to all be leased, and then after the breakup and several other legal actions, they became possible to buy them third party, they had to lay down in black letter exactly how the line behaved, so that third-party manufacturers, if they made a phone that didn't work correctly on the universal standard line, the phone company could just say, that's your fault. You didn't do it right, because our stuff all behaves exactly the same. This was true for an incredibly long time, and it still is, even though internally the lines that you get from the phone company nowadays, if you even have landline service, behind the scenes work completely differently than the way they did 20 years ago, 40 years ago, or 60 years ago. They've been through several massive generational leaps in how the signals actually generated. The actual characteristics of that line are going to be damn near identical to the way they were half a century ago or longer. For the same reason, the phone company is maintaining a legacy service which has to support decades and decades and decades, or in some cases over a century of hardware. They don't want to find out that because they upgraded the line cards in a given neighborhood, that a bunch of people who've been using the same instruments for decades suddenly can't use them, partly because that would be a violation of federal regulations, and also because it's just a huge, miserable support headache for a product they'd really rather not think about at all. The end result is that an awful lot of things that used to work a long, long time ago still work. For instance, an example of this is pulse styling, what was used by old rotary phones back in the 40s, 50s, 60s. Pulse styling has not been a mainstream thing. You haven't been able to buy a phone that did that in 30, 40, oh gosh, I guess probably almost 50 years at this point. But the last landline I tested still supported it. And in fact, a lot of voice over IP ATAs also support it. I've got at least two here that I know for a fact do a great job with pulse styling. And the reason, again, is just because once you have that technology, once it's working and it's a solved problem, you don't ever want to shut it off, because all these people will come crawling out of the woodwork whose problems might be petty and completely unjustifiable, but they'll still become your problems. As the telco, you don't want to know your customers exist. Every corporation is like that, but telephone companies have such a broad service base that they really have an imperative to never deal with you directly. So not breaking your shit is really in their interest. Voice over IP is not like this. To a certain extent, VoIP vendors and providers want to keep your old shit working. Sometimes, like for instance, if you're Vonage, are they still around? I don't even know. I don't remember the last time I heard about Vonage, probably because mostly people are just getting rid of landlines and switching to cell phones. Even if they're like old folks, they're getting, jitterbugs and whatnot. But at least for a long time, Vonage was the largest voice over IP carrier in the United States. But their primary product was not what a lot of people would think of as VoIP. Let me expand on that. Okay, almost all my VoIP phones are in a big tangled mess, so I had to grab this one. This is very, very old. This is a Cisco phone, which they actually acquired from Linksys, who in turn acquired it from a company called Sapura, who were making these before almost anybody else, but I digress. And this thing is a whole ass computer. Like, it's got a microprocessor in there that I think runs some very slim variant of Linux or VxWorks or something like that. And it's got software on it that makes it act like a phone, but it's got Ethernet ports on the back of it. You plug it in your network, it connects to a VoIP service provider or to a PBX, and everything it does is just IP packets, right? It's Skype, okay? It's hardware Skype. Does anybody use Skype anymore? Oh geez, I'm getting dated here. I have no idea if Skype is even still up. WhatsApp, Discord voice, whatever. Anyway, the point is, that's the real VoIP. And there were people back in like 1996, 98, when the technologies were first being ratified, who thought that phones like that would take over. That didn't happen. It's never going to at this point, because again, we're essentially all just switching to cell phones, and the concept of the stationary landline phone, no matter how it's connected, is just becoming obsolete. But it's taken a very long time for that to happen. Back in 2004, the idea of switching entirely to a cell phone was a much less reasonable proposition for a lot of people. And so companies like Vonage made a huge business out of selling these ATAs. Did I ever define that? That's analog terminal adapter, by the way. And the idea was that you'd get the benefits of VoIP service, not having to pay a separate fee to the phone company, not having to maintain a separate physical phone line. You just get your internet connection, and then you'd pay theoretically a much smaller amount to Vonage to run the IP service that supports this thing. And then you just plug the phone you already have into it, upside down, and then this thing would generate a fake dial tone, and grandma can continue using the same Western Electric 2500 set that she's had since 1981. But here's the thing. Vonage is primarily targeting the Western Electric 2500 set at worst, and at best they're expecting something more like this, like a mid-90s device that's full of modern circuitry. The ringer draws very little current compared to the physical bell in this guy, and well, it's a newer device, and it's much more consistent than a lot of the cheap older instruments that used to exist. But also, it's a lot more consistent than what you'll find in, well, other stuff that's not a phone. Fax machines, for instance, can have very strange behavior on the phone line itself. And then you've got like caller ID boxes and many other things that aren't necessarily just a telephone, all of which may not actually work on this or this or this or any other ATA. It's not super common that you run into something like this. Frankly speaking, most devices will work on most analog adapters. But for instance, none of these will ring the physical ringer in this phone because there just isn't enough current coming out of the ring generator on board. There is an exception. This Grandstream, I think it's a HT502. Yeah, these guys actually will drive a physical ringer, but they're the only ATAs I've found that will do it reliably. And beyond that, there's just strange behavior as far as how the signal processing works. There are some devices out there, like phones for the hard of hearing with built-in amplifiers, for instance, that when plugged into an ATA can just kind of go bonkers. You can get just nutty feedback and weird sounds, high frequency pitches coming out of the speaker and whatnot. And the response from the manufacturers of these things, when you tell them that, is to go pound sand. I've been on the other side of this several times. They don't care. They're not interested in making your device work. In fact, remember I mentioned this company Sapura? These guys were making voice over IP stuff back in like the late 90s, maybe even earlier, like 96, something like that. They were really pioneers. This device here is called the SPA 3000. And when these folks got acquired by Linksys, it got renamed to the SPA 2100, I believe. And then that got redesigned into the SPA 2102. And then Linksys got acquired by Cisco, and Cisco continued selling it under that name before they renamed it to the SPA 122. And it's now been renamed to the, I think, ATA 199. They're all the same. They're all the same. They've got the same chip. They run the same chunk of firmware. They've slightly prettied up the user interface, but there's been essentially no development on this product in 3 decades. And I think this is what's being deployed still by a whole lot of voice over IP providers. So I don't think that Cisco has any employees who actually know how those work. And certainly they have no financial interest in making them any better. So if something doesn't work, they don't care. They'll just tell you, go buy a different thing. And I'm telling you, I've seen this happen many, many times. They will make no effort whatsoever to do diagnostics. They don't even know how to do diagnostics. If something doesn't work, They tell you to replace the thing because they're not bound by any federal regulations. They're not a phone company, and what they make is not a phone. This does not fit my needs. I have personally run into things that don't work on these ATAs. For instance, back when I did that video about the simultaneous voice and data modems, which is probably my best video to date, by the way, and if you haven't seen it, I really recommend it. I just watched it myself the other day and I was like, wow, this is really vain watching it. I found that several of the modems that I was testing wouldn't work through the ATAs. They either wouldn't connect at all, like they would establish a basic dial-up connection, but they couldn't establish the voice channel. Or they would connect, but they would have weird like audio feedback effects, or they would like have really high noise and then they would just drop out periodically. And then I tried running them through this thing, and that didn't happen. They worked perfectly. If you watch that video, you'll see me using this thing. Well, the reason for that, I believe, is that the ATAs are incapable of not digitizing the signal. I think that as soon as the audio goes in here, even if it comes right out the other jack, it's still being converted into a digital signal in the process, and it's using whatever front-end circuitry Sapura developed back in 1997. So it's got quirks. It's got weird, harmonic whatever. It's got strange front-end behavior that you would never experience from a real phone line. This thing, on the other hand, I believe is all analog. I think that this works a lot more like a traditional piece of telco switching gear. It's generating the ring signal and the dial tone and doing the actual physical switching of circuits together, all in the analog domain, as far as I can tell. Certainly, I don't see why it would be digitizing anything since it has absolutely no digital features. There's no Ethernet interface. There's no way to slurp off like a bit stream or anything. So it would be silly for them to have bothered. And sure enough, I found this thing to be completely reliable. Everything that I've done with it has worked perfectly, including, for instance, that's on the wrong port. That was such a fun little demo I was about to do, and then it was on the wrong port. That's the wrong phone. I still look like a fool. This is going great. My demonstration is really going fantastic. Oh, there we go. It rings the mechanical bell in this thing, which, as I said, a lot of devices struggle with. Even PBXs with very expensive analog line cards often struggle with mechanical ringers. So this thing is absolutely terrific for my needs. So I'm really lucky that I found one for less than $400, which is what they're still going for on eBay because I don't think they've been made since like 2004. But it also is sort of a PBX in itself. It's kind of vague exactly what that means, but as I mentioned earlier, PBXs give you capabilities with your business phones that are not generally available from the phone company, or if they are, they require getting a lot more physical lines from the telco than you'd like to pay for. For instance, conferencing. Generally speaking, if you have 4 ordinary phones hooked up to 4 ordinary phone lines, it's a real pain in the ass to get them into a conference, and I think actually, you know what? I don't know if you can do a 4-way conference with conventional telco features. I know they'll do 3-way, but I'm not sure if it goes any further than that. Whereas with a PBX, it's absolutely trivial. And this device provides that feature. Now, you could just get a PBX at that point. The trouble is, PBXs are a huge pain in the ass. I need to do a video about PBXs at some point, because I bring them up periodically in videos when I'm talking about other stuff, but they're such a complicated subject because they have unlimited internal flexibility. That's really the best way to put it. If I start giving any examples, then I'll just get bogged down in this, but there's just infinite ways to route and split and combine phone calls and unlimited amounts of internal policies that PBXs can implement. And the end result is that, sure, you can buy them on the used market for very cheap, but then you have to teach yourself how to operate them, and it's never easy. It's in order to just get 2 extensions to talk to one another, especially if they're analog phones rather than dedicated proprietary phones for that PBX, you could be looking at hours of effort, and then even after you're done with that, the next time you want to do something with the thing, if you need to change some of that behavior, you've got to teach yourself how to run it all over again, and it's incredibly tedious. You're talking about, you're sitting at a phone, staring at a manual and punching in these long strings of numbers to program the system completely blind. It's not a fun job. I've done it before for work, and I don't want to do it again for play. Well, I guess this is my job now. Well, I still don't want to do it if I don't have to. And this thing makes that totally unnecessary. If you just set this to factory defaults, it lets you just call between the ports right off the bat, which is 95% of the time what I want. And then if I want to do something like assign a phone number to one of the ports, let me get the manual here. I'll do it right now. Watch. Okay, so first off, the manual says you can assign 2 different phone numbers to each port, which is really convenient, and each one can be up to 16 digits long. I think that supports all possible international number formats, but I could be wrong about that. So the first number uses a normal ring cadence, and the other uses a non-standard one. What that means is when you call the first number, it just goes ring, ring. But when you call the other number, it can go ring, 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 ring. So you can tell which number is being dialed. It's called distinctive ring, I believe, and it is a feature that you can get from the phone company. And you can also see you can vary, for instance, the ring type, the frequency, and wave shape. That's for use with phones from other countries, that sort of thing. Group ringing, you can dial a number and it rings all the other ports. Call waiting tones. This thing actually supports call waiting because if you're testing a device that actually depends on that functionality, and there are such things, modems, for instance, then you need a way to generate that. There's also caller ID support, and I'll bring that up later. You can also do a hotline mode, and that means that you could program this so when you pick up line 1, it just instantly rings another line. A behavior that's actually really common in PBX systems. For instance, you have a hotel lobby phone. When you pick it up, it always just calls the operator. And it even supports features that almost nobody knows exists, like automatic callback. I've never heard of anybody actually using that, but every phone system has supported it for decades and decades. Basically, it allows you to squat somebody's phone number. Like, suppose you call somebody and you get a busy signal. You can hang up your phone, dial a star code, and then when that person hangs up, your phone will ring. You pick it up, and then it dials them automatically. You know what? There's actually a feature I didn't even realize this thing had. Silent off hook mode. How do I set that up? If that does what I think it does, that is super useful. Okay, first I'm going to assign a number to one of these ports. So that is star 11. So we enter programming mode. Then we pick a line. Put in whatever number we want. And there we go. All right, now I should be able to dial that number. And there we are. Now, you can get to the point where you can understand how to program a PBX that quickly. The problem is that there are thousands and thousands of potential commands, and they deal with an unlimited number of extensions. Whereas this thing has a fairly finite number of commands. They only deal with 4 extensions, and that means that the manual can give you explicit instructions on how to do every single one of these things. I just followed these instructions right here. And I can tell you that most PBX programming guides are not nearly that simple. Now let's see if I can find that silent off hook thing. That looked really cool. Now here we go. Star 3, 2, pound 2, pound. Okay. Hang that up and pick this up. Ah, excellent. Okay. There's no way for you to hear this, but when I pick this up, I just have dead air, except it's not dead air per se. Let me just unclip my mic here. Maybe you can hear this, but when I speak into the mic, it's coming back out of the speaker on the phone. And even if you couldn't hear that, you're probably familiar with that phenomenon. When you pick up a phone, whether it's on a call or whether it's dial tone or not, as long as it's connected to a phone line that's not completely dead, you can usually hear your voice in the speaker. It's a phenomenon called side tone. And I've never been clear on whether it's on purpose or not, but in any case, it's universal to all phones. Even voice over IP phones simulate it because it's what people expect. But the reason this is interesting is that, well, typically, if we take a phone off the hook, we get dial tone, right? But if we just wait for a bit, I'm waiting now, I'm waiting. We get slow busy, telling us, hey, buddy, you left the phone off the hook. And then I believe on a real conventional phone line, you'd get a thing called howler, a tone that's incredibly loud and is meant to let you know that you left the phone off the hook if you're maybe in another room and forgot about it. And if you're trying to test something that needs to be connected to an active phone line, but you don't want to keep setting up a phone call every single time that you test it, then being able to just pick up the line and instantly get that side tone, which is really just the presence of the 48 volt DC current that's standard on a telephone line, but without the dial tone or any of the progress tones or the business signal or anything like that. Not having to wait for the line to time out before you can use it like that is fantastic. And there's just a million other things you can do with this. Not nearly as many as a PBX, so it is much simpler. It took me 5 minutes to figure out how to do this thing I'd never done before. So yeah, the thing pretty much justifies itself as a piece of test equipment. And at first, when I got this, I thought that's what it was, like an actual piece of laboratory gear, something you would get for certification testing, that sort of thing. If you were designing like a fax machine or something, that this is the device you would connect it to verify that it works on a real phone line. But it's actually not. There are devices like that. I used to own one. It was this great big 4U 19-inch rack unit thing. It was like 20 odd pounds. And the whole thing was designed just for that purpose. It was incredibly baroque. I had no idea how to use it correctly. It had tons of features in there to do things I never wanted to do. Basically, its function was to simulate a phone line that wasn't like all the others. Because I know I made that whole tirade earlier about how all phone lines work exactly the same. That's how they work by design. But the reality is that phone lines come from a central office run by the phone company, and they go either through the air or underground. They go through junction boxes, and sometimes they degrade. Frequently they degrade. They get corroded. They get, rainwater ingress. They get, dirt and whatnot gets into an underground vault, and the wires get all screwed up, and then you get voltage loss. You get noise, scratchiness, and there's all sorts of other things that can happen. Things like amplifiers and load coils on the line, and interference from other circuits and stuff. And you need to simulate all that stuff if you're developing a piece of equipment that's going to plug into a phone line, because you can't rely on the phone company fixing that sort of thing quickly or ever. Like, yes, they are required by all kinds of regulations to do so. The reality is they usually don't do much about it very quickly, and in some cases they actually can't. There are some people that are out in the middle of gosh darn nowhere, or they're in very densely populated places like San Francisco, where the practical reality of running a whole new phone line just to fix one subscriber's service is an enormous expense, rather than just telling them, sorry, good luck, have a nice life. And despite all the regulations in place, this happens more often than you'd think. There are some people who just simply cannot get good phone service, ever. And when those people were able to switch over to cellular or voice over IP, they actually got much better phone calls for the first time in possibly decades. In any case, you get a device like this when you're designing like a fax machine, and you want to make sure that it works even if the line is pretty screwed up. So you can have this thing introduce controlled amounts of noise and impedance issues and echo and all sorts of other stuff, none of which I want to do. And this huge hulking device that I did not at all understand how to operate only had 2 jacks on it. So I never figured out how to get it to just give me a clean line, and even if it did, it would only let me plug together 2 devices. I want to plug together more. So it really wasn't even up my alley anyway. But this thing isn't actually meant to do what that did at all. It's actually for trade shows. Once you've finished making the fax machine and you take it to CES, if you can believe that, they actually have had things like this on display, you want to be able to set up your machine and let people come by and test it without needing to bring in physical phone lines from the phone company, which is probably impossible. So you set this thing up in your booth, you plug in your fax machine and another one, you assign, short, simple numbers to them, and then someone can come in and just dial a number and see a fax go through. And you don't have any dependencies on any outside systems, but you also didn't need to bring along a big hulking PBX and configure it. So it's a really neat device that's intended for exactly what I'm doing, demonstrations. But there was one other use case listed in the pamphlet for this thing that I thought was really interesting. They say you can use it as a teaching aid. And an example they give is if you're trying to teach kids how to use 911 responsibly. I'm trying to picture this scenario. I guess you would have somebody playing the 911 operator and then the kid on another phone, and then you want a third party to be able to hear their conversation. There's a audio jack on the back of this thing. It's just a 5-pin DIN plug, which you can configure to output the audio from one or many of these jacks, which, as you can see, is what I've done here. I just built a little adapter cable, and it allows me to record whatever is happening on the phone directly into my Tascam.
Obviously, this is incredibly useful for the sort of stuff that I do. You know what? This phone sounds terrible. Hang on. There we go. That's a hell of a lot cleaner. Obviously, this is incredibly useful for the sort of things that I do on this channel from time to time. For instance, going back to the video about the SVD modems again, this is how I was able to get the sound of the modems dialing up and of me screaming over the modem carrier. There are ways to get that signal directly off the phone line itself, but I personally have found them less convenient. Tapping a phone line into a digital recorder is kind of a weird pain in the ass for some reason.
But doing it this way was really straightforward, and I was really glad that I had this thing. Although, for that specific video, it actually didn't do everything that I needed because of how strange those devices were. You see, the SVD modems, if you didn't watch the video, their special property is that they would let you place a call while you were on a dial-up call to another computer. You could actually speak to somebody on a physical telephone or on a headset while you were sending data back and forth. And it did this by establishing an audio channel inside the modem signal. Well, as a result, if you listen to the audio tap, all you hear is noise.
In fact, if I pick up the phone, you can hear the modems screaming away at each other. That's what's actually happening on the phone line.
So what I had to do was to get the audio off the phones themselves. And again, while it's theoretically possible to slurp it off of the phone line itself, I've not had good experience with that. What you want to do instead, ideally, is to get it directly off the handset itself. And this is something people have been doing for many, many, many decades, and there are great solutions to it. Well, okay, they didn't used to be great. If you go back to the 40s, the 50s, to some extent the 60s, if somebody wanted to record a phone call, well, here's the thing. Back then, phones were leased from the phone company. You didn't own them, and you weren't allowed to do anything with the wiring. So what we became used to later, the modular plugs that let you unplug a phone or unplug the handset from a phone, those didn't exist, I think, up through the mid-60s. Phones were all hardwired. There was just a rubber boot back here, and the cord went into the wall, and that's all there was to it. If the cord got damaged, you called the phone company. If you wanted to move the phone, well, that's too bad. You just couldn't do it. Likewise, if the handset got damaged, you just had to have them come out and swap out your set. So that meant there was nowhere to get in, legally at least, to intercept the audio signal. So instead what people used were inductive pickups. I sadly can't find either of mine. I had two different variants, but the more common one that I've seen is a suction cup that you stick on the back of the handset, which is possible because the handsets were both flat and shiny, like they're smooth, so they make a good seal. And those had a magnetic coil inside, which would inductively couple to the speaker in the phone and thus replicate the audio. And that worked because these things were pretty barbarian. Phones used to deal with fairly high wattage signals. If you take a look at the components in here, this is the microphone. This is called a carbon mic, and it's a pretty barbarian device. Likewise, the speaker is not a small thing. There's a lot of mass to this guy. I don't know what the amplitude of the signal actually was, but later on when we got into semiconductor-based phones like this, they started using much tinier components, little electret mics and much smaller speakers. So I don't know that you could actually use an inductive pickup with something like this. I wish I knew where mine was. I would test it out. I also had what seemed like a much better approach to this. Rather than sticking a suction cup on the back of the handset, I had a coil that would slip over the front face of it. And that seemed like it would get a lot closer to the speaker and get a better signal, but I lost that one too, so I can't exactly compare them. Anyway, later on, once they started designing phones with detachable handset cords, this gave you a much better option because you could just intercept the signal right here, and that's exactly what people started doing. I've got one of those taps right here. This guy just spits out a 3.5 millimeter mono jack, and we just spin this around, unplug the handset, and then plug it back in here, and there we go. Surely I have a 1/4 inch adapter. One moment. Let me go get one. Okay, deeply embarrassed by how long it took me to find just a 3.5 to quarter-inch adapter. Let's give this a shot.
So this is what it sounds like coming off the tap on the device itself.
And then this is what it sounds like coming off of the handset tap. And I'm just going to guess that it probably sounds a little bit better. Although actually, I wonder now that I think about it, because phone handsets have independent mic and speaker, whereas the line going out to the device combines both signals into one. Now this thing, I don't think would be capturing both signals together because I think they're at very different amplitudes. So I noticed that my voice is not being picked up very loud by the Tascam. I suspect that's because we're only getting the side tone component coming off the speaker here. So if I were to call myself... Okay, so now I'm guessing my voice is going to be quite a bit louder since we're picking it up coming straight out of the speaker instead of through the mic on the handset. But I guess I'll see in post.
But anyway, that very long digression aside, these things are useful if you're a YouTuber doing a lot of demonstrations of phones, or I guess if you need to record your phone calls, assuming it's legal where you are, which has always been a very complicated subject. But these have always been available for purchase ever since the detachable phone cords came into existence. But there's a much more broadly useful application for being able to intercept the handset signal like this. As I think I mentioned, the microphone and speaker signals are separate when they go to the handset. This is actually important because suppose your phone isn't loud enough. As I mentioned, phones are very simple devices, at least they used to be. This thing is powered directly off the phone line itself. So there's a signal coming from the phone company, and depending on how long your phone line is, it might be a little bit louder or a little bit quieter by the time it gets to you. And then suppose the person at the other end of the call isn't talking very close to the mic, or their phone just sucks and isn't picking up their voice very well, or they're on speakerphone, or any number of other things. Well, generally speaking, there's no way to make somebody louder because the phone doesn't take any power except what's coming off the line. And generally speaking, I don't think there's enough current there to run an amplifier. At least I don't think I've ever seen a self-amplified phone that didn't have like a separate power supply that plugged into the wall. And that's not always practical. Maybe you just prefer a particular phone and don't want to replace it with one that has an amplifier. Or maybe there's an accessibility reason that you can't go with any other phone. So what you'd really like to do is just make the phone you have louder. And once they added the modular cords, that became a lot easier. You couldn't really just amplify the signal as it came into the phone, partly because the signals are combined, so you'd be pushing up the sound that you hear locally, but also amplifying your voice as it goes back out, which could blow out your voice. If it was already loud enough, it might be too loud for the person at the other end. And you're messing with the signal that's going out to the phone company, and that's generally a no-no. I won't get too deep into that, but there's really complicated laws around it. However, in between the handset and the base, that's pretty much free real estate. There probably are actually regulations around that, but in practical terms, anything you do there is not likely to make it out into the world. But also, you can put an amplifier there that will only affect the speaker and not the mic, and that's what this does. This is a Ameriphone handset amplifier, and all you do is plug it in here, and then connect the handset to the pass-through. Oh, you know what? I just noticed. Oh, there's an auto manual switch on here. I have no idea what that does. What does that do? Well, okay, let me show you what it normally does. So we pick up the phone here. Ooh, that is really quiet. But if we turn it all the way up, it's not working. Because I took the battery out. Look at me getting mad at myself because I did the thing you're supposed to do and took the battery out for storage. Only a doofus would do that. Only a fool. Okay, this should be considerably more impressive. Okay, still pretty quiet there, but you can probably actually hear it at this point. It's very loud. It doesn't seem to be nearly as loud as I expected. What if we put it on manual? Does that get any louder? That's pretty loud, I gotta say. The other day when I tested this, I think I was using a different phone, and it was so loud I couldn't put it any closer to my ear than this. So maybe this guy's at fault. Maybe it just produces a low amplitude signal. I don't know. So anyway, these used to be very common accessibility devices, and I don't know what was used, if anything, before those existed, before the modular phone cords existed. I imagine that probably the phone company sold some sort of amplified device, but I don't know that I've ever seen one. And it's one of the few cases where I'll actually argue for the capitalist, free market approach, because I wouldn't be surprised to learn that AT&T never made a phone that worked for certain people's disabilities, whereas American Phone Products in Huntington Beach, California, suite number 5. Yeah, that was probably 3 dudes and a desk. If they saw some small profit in it, maybe by, raking insurance companies over the coals, as is the American tradition, then you might have been able to get what you needed. It's the incredibly rare case of the system actually working. If only that happened 95% of the time instead of 3% of the time. Anyway, moving on. Let's look at my butt set collection. No, I am not referring in any way to my ass. So this is a variety of butt sets, and I have no idea where the name comes from. I doubt it has anything to do either with butting in or with the fact that it hangs off your ass, although that is the purpose of these things. They're tools for linemen, that is, people who work on the lines, guys who climb phone poles, that sort of thing. That's why every one of these has a big old hook on the bottom, because you're supposed to hang it off your belt like yay, so you don't have to keep it under your arm while you're climbing up a pole. And for the most part, these are pretty much just very compact portable phones, but they do have a number of special features of interest to technicians. Okay, so chief among their features is the clips. Obviously, a normal phone plugs in with a phone cord, but if you're doing diagnostics, you might not be able to get to a phone jack, or you might be diagnosing the phone jack. And if you're working in, say, a B-box, those are the big metal junction boxes out by the side of the road that you rarely see open these days, but they're where all the phone lines from the telco central office come in and then get junctioned to the wires that are going out to subscribers' houses and offices. And if you're working in one of those, you might not necessarily know where the line that you're looking for is. You might not know where the failure is. There might be a broken wire anywhere in the terrifying mess of wiring that's in there. And there aren't going to be any jacks. It's all just punch-down panels. I'm going to show you one of those later, but just metal contacts with raw, bare wires spiked down onto them. So you can't plug in anywhere. You've got to be able to just attach to the bare wires directly. So to this end, we've got these very funky clips. They're not like alligator clips. They're a lot more specialized. And in fact, I'm going to show you why they're shaped like this on the end much later in the video. But obviously, you can use these to clip on to bare wires if you've got them. Most of the time you don't got them, but what you do get is you get screw terminals, at least if you're working in somebody's house, for instance. It's a very good chance you'll find a box somewhere, at least in older houses, that has screws like this. And of course, you can just clip on to those directly like yay. But in a lot of cases, you can't get to any kind of bare metal because phone wiring, it's all insulated wires, right? And they come in these big bundles. You don't really want to pull out one of these little tiny wires and have to strip the end off of it in order to work with it. And in a lot of cases, you actually can't do that for complicated reasons. You might literally not be able to get to a place where you can remove the insulation from the wire. So these have insulation piercing connectors. This thing right here is what's called a bed of nails clip, and it's literally just a bed of nails. There's a bunch of little steel spikes in there. They're not tremendously sharp. It's not hurting me, but there's a little anvil here, and if you put just a bare piece of wire right there and squeeze it down on there, it'll punch through the very thin insulation and touch the copper inside. Now, most of the phone network is wired with very, very thin wire. If you've ever worked with Cat 5 or Cat 6, it's basically the same stuff. Looks like this. It's a solid core. It's like 26, 28 gauge, something like that. Quite small. Now, the bed of nails has no trouble getting through the insulation on one of these wires. There we go. Oh yeah, that's in there. But in some cases, you might actually be dealing with something that's 18 gauge, 20 gauge, something like that. I don't know where this comes up, but it does apparently come up from time to time. And the bed of nails isn't big enough. So you've got this great big spike back there that could punch through the jacket on much thicker stuff. Now, you might be wondering, wait, you're just going to mess up the insulation and then just leave it that way? Isn't that bad? I'm not an expert on this part. I've never heard this explained from the telco perspective, but I can guess that the reason this isn't taken as a big deal is because the insulation on these wires, well, it's not the most robust stuff in the first place. It's really just sort of the suggestion of insulation. And it's there mostly to keep the wires from touching each other or shorting out against a cabinet or something like that. And a set of little micro perforations isn't really going to interfere with that. And generally speaking, these should be hanging in free air. They should never be, buried directly underground, soaking in a puddle, that sort of thing. And to the extent that that does happen, the system has to be able to tolerate it. So I think that up to a point, as long as you don't have like inches of bare copper that are swimming in salt water or something, everything's just meant to be tolerant enough to put up with a little bit of high resistance shorting between the leads here or there. And of course, if you're working on something, the effort and potential interruption in service of having to disconnect dozens or hundreds of wires and interfere with people's service while you're trying to find an affected line pales in comparison to the very minor impact of putting some little tiny holes in one or two pieces of wire. People who have actually done this might have different opinions than mine. I may be missing something big about this, so I expect to get some comments about that. Now, I have 4 butt sets. This one here is made by Jensen, but I think this design was originated by a company called Harris. It seems like that's the most popular name I can find with this particular shape. I remember my dad had one of these, looked exactly like this back in the 90s, and this is the most common butt set that I've seen out in the world, but I don't know if they definitely originated it or not. Now, one thing that might stand out to you is this thing only has the clips, so there's no way to just plug it into a normal jack. Well, the solution for that is a thing called a banjo clip. It's expected that most of the time you won't be in a situation where you actually have a jack to plug into, but if you do, then you get one of these, you plug it into the jack, and then you just clip these onto the wings. I actually don't have one of those for reasons, but I have something that'll work in a pinch. I'll talk more about this thing later. This takes the 2 wires in an RJ11 and splits them out to banana clips. It's not super ideal, but it works well enough. Now, I actually don't like this butt set very much. It's not my favorite butt set. It's sort of finicky, and I don't really like the user interface. So right now, this thing is in monitor mode, which means if there was any audio on the line, like if I clipped onto an active phone call, I'd be able to hear it. But if I want to use this thing to place a call, which obviously we can do, then I slide this into the talk position, and nothing happens. Sir, I wonder if I've got the leads backwards. It's happened before. Nope, this thing has stopped working again. Terrific, terrific. So I actually thought this thing was completely broken for many years. I've had this since like 2020, and I never got it working. And then today, I decided to open it up, and I found it takes a 9-volt battery. And I'm like, oh, so the battery's dead. So I replaced it, and it started working for like 5 minutes, and then quit. So I checked the battery, and it was at like 8 volts. And I'm like, okay, so I put a dead battery in it, I guess. I replaced that, and it started working again. But here we are, it's dead again. So I think this thing might have like a high resistance short in it that's just draining the batteries really quick. That sucks, but it's just as well, because like I said, I don't like the thing very much. But you can grok basically what it does. It's got a dial pad on here. You can do either tone or pulse dialing. And otherwise, it's mostly just a phone. It does have a built-in amplifier because it does have a battery. You can make the speaker much, much louder. And the reason for that is you might need to like hook this onto a line, leave it somewhere, and then go across the room to work on something. So this can get super loud so you can hear what's going on. Well, it's kind of a bummer that that's dead, but I think at this point I'm just gonna throw it away because I never liked it very much to begin with. Let me show you my favorite butt set. This one here is from a brand I have never heard of, HD Telecom Inc., out of Fort Collins, but it's made in France, which I didn't really expect. I wonder if this is probably just rebranded from some French telecom company, something like that. But this one has a number of features that I prefer. I actually outfitted this with an ordinary RJ11 cable because, well, frankly, for me, most of the time I do just have jacks to plug into, so this is more convenient. But this does, again, just basic phone stuff. In ring position, if we call this thing, it rings like normal. And then if we switch it to talk, that takes the line off the hook. And you can see right away, one nice feature is this guy right here. That green light indicates that the jack is wired correctly. It shows that it's straight through, whereas this would indicate that it was backwards. Interesting things happen if you hook a phone up backwards. I can actually demonstrate this. I mentioned earlier that phone lines have a constant DC voltage on them. It's nominally 48 volts. It's called talk battery. It's used for a number of things. With the original telephones back when the system was new, like I said, they used carbon microphones. And the way those worked is there's basically a bunch of carbon granules inside this thing. And then there's a plastic diaphragm. And when you speak into it, it basically just squishes the granules together and reduces the resistance of this whole module. So if you feed DC voltage in one side of this and then talk into it, it'll modulate that voltage, producing a voice, right? So the original phone system was literally nothing more than just these carbon mics and then speakers and then a battery in the middle of the circuit. At the other end, the other person had the exact same thing. So your voice went down to their end, went through their speaker, then it went through the mic, their voice modulated it again, and then it came out to your side and the whole process repeats. It was essentially just one big current loop from end to end. So in this era, I don't know if it mattered which direction the line was hooked up. I don't think that there's anything in a phone of this age. I think this is like a mid-50s, I want to say, Western Electric Model 302. I don't think there's anything in there that's polarity dependent, because this being a rotary phone, it dials by simply connecting and disconnecting a switch across the line. That doesn't depend on polarity, and neither the mic nor the speaker should particularly care. So I don't think it mattered back then, but when we move forward to the mid-60s, when they started introducing touch tone, these buttons here connect internal frequency generators, and those are polarity dependent. So if we hook this phone up, with this cable plugged in, if we go off hook, we can dial numbers like you'd expect. But let's unplug this cable and swap it for this guy here. So these are technically both quote RJ11 cables, but you'll notice that this one has only 2 contacts, the one's right in the middle, whereas this one has all 6. And apparently this one uses a straight through wiring scheme where, you know, pin 1 goes to pin 1 and so on. But the other one, I guess, crosses the wires over in the middle, and I think that's how it's supposed to be. So I didn't realize that this is actually inverting the signal. So if we go off hook now, we have dial tone like normal, but can't dial. And from what I understand, that is caused by having the wrong polarity. Is it possible to plug that into this set and prove that? There is a jack on here. Does that accommodate? Nope. That is a RJ12. That's a handset jack. That's a pain in the ass. Do I have a coupler? Okay, I don't actually have a coupler, but I do have this mess, which I promise, I know it looks like a disaster, but these are just wired up the same, all 4 jacks here. So let's hook this up and see if this will recognize it. Oh, it does. And it says that it's wired straight through. Huh. Well, this thing's definitely not the problem, so let's try the other cable. This is the one that was working on my 2500 set. Oh, and it says that one is wired backwards. Well, I trust the butt set and I trust the coupler, so I think it must be my phone. Well, I guess I wouldn't be that shocked if at some point in this thing's long history, I've had this thing for decades, maybe somebody opened it up and changed the wiring. I don't know why they would have, but, well, there we go. We just did some diagnostics. That's exactly what the butt set is for in a nutshell. I haven't even made a phone call with one of these things yet, and we've already diagnosed an issue. Clearly, this phone is the problem and not my wiring. Although we did just determine that these cables are not wired the same way, which is interesting because I've used both of them on this set and they work just fine. Now, this one is much newer than this one. I think this is from the mid-70s, something like that. This one, I would guess, is from late 80s, early 90s, and presumably it's a lot more sophisticated. So probably Sony put a bridge rectifier in there so that regardless of which way the wires are connected, it still works. And the reason for that is these were made by Western Electric. Basically, they were made and sold by the phone company. So if your phone didn't work because the line was inverted, then they'd come out and fix it, maybe bill you for it, but that was the correct solution. Sony, on the other hand, has no control over that. They just want the device to work. They don't want to get a return from a customer who's not interested or able to get the diagnostics done to figure out why their device isn't working. So they just make it universal, and then that solves the problem. But anyway, what else can we do with a butt set? Well, we can eavesdrop on people. First off, let's just make a phone call with this thing. We'll just put this in talk, dial our other phone. There we go.
And there we go. It's just an ordinary phone. Actually sounds really good, at least from what I've heard on the Tascam. This is one of my better sounding sets. Let's see, let's compare to this set. I don't know, this one might be a little less harsh. At least the side tone on this guy sounds very kind of crisp and sibilant-y, but maybe you like that. Personally, I like it. I think it sounds great. And it makes sense that this would sound good because I think it's a pretty late model. I think it's from sometime in the 90s at least, and probably wasn't cheap. Butt sets are usually, I think, a couple $100, so they could afford a decent mic.
But anyway, that's the most basic thing you can do with it. What can we do that's not just a phone call? Well, the most interesting feature on here is MON, or monitor. This allows you to hear what's on the line without going off hook. Let me explain. When you pick up a phone, there's a physical switch on the phone. And that connects, I think, a resistor, like a very low resistance resistor, across the line. So it doesn't completely short it out, but it lowers the impedance on the phone line a ton. And that allows the equipment at the phone company end to notice that you've gone off hook, at which point it starts giving you dial tone and starts listening for digits. Maybe that seems odd, and I don't want to go too deep into this, but I figure I'll just explain it. For the first 70 years that the phone company existed, they didn't have enough equipment to handle service for all subscribers simultaneously. They still don't exactly, but they have a lot more coverage than they used to. Back in 1976, if you picked up your phone, when you got dial tone, you were connecting to a machine at the phone company office that was just there to listen for dial digits. And they only had a small number of those. So if 100 subscribers picked up their phones simultaneously, some of them wouldn't get dial tone because there just weren't enough digit receivers waiting for them. So they didn't want to present dial tone to all lines at all times. They want to wait until someone's actually trying to place a call. So on-hook, off-hook status is really important and very well defined. And it means that you can actually attach stuff to a phone line, and as long as the impedance doesn't go low enough, it won't trigger an off-hook state, which is important because suppose you're a lineman and you've got your clips and you're going through a B box trying to find, a line that's having a specific problem. If every time you touched a pair of wires, you went off hook on that line, you might interfere with ongoing calls. You might answer a call that's ringing at the moment. And then as soon as you pull your clips away, it's going to hang up on that person. There's lots of reasons not to want to do that. So these devices by default are in a high impedance or a high Z state where they'll let you hear what's on the line, but they won't affect the line. Now, if I'm just plugged directly into a jack, that doesn't really do anything for me because the line's not off hook. But let me show you something. I'm going to plug this into line 1 for a very specific reason. One of my favorite features on this box is that if you press up on the power switch, it will just send a ring signal to the first port, no matter what else is going on. There's a lot of cases where that's useful. If you don't actually want to place a call or you don't have another phone handy, but you need to ring something like a fax machine or a modem, for instance, to see if it'll automatically pick up, then that's really handy. But it also means I can do this. We put this in monitor, and we ring it. Let me hold that up to my mic. Hear that? That's what the ring signal would sound like if you could ever hear it. But normally that's impossible because the phone company will only send a ring if the line is on hook. If it's off hook, then, well, they just send a busy signal back to whoever called. And as soon as you pick up, the ringing stops. So normally you'd never be able to hear that sound. But because this can monitor the line without answering the call, you can hear the ring. And you can hear things in between rings. Let me explain. Have you ever wondered how caller ID worked? Probably not. Most people haven't, especially nowadays. But back in the day, caller ID was introduced in the oh geez, mid 80s, late 80s, I want to say, something like that. It's a pretty old technology. And originally you would buy a dedicated box that would sit next to your phone. The line went into it and then back out to the phone. And when you got a call, shortly after it started ringing, your caller ID box would tell you who was calling. Someday I'm going to do a video about voice over IP, and when I do that, it'll be a great opportunity to explain why you can never trust caller ID. It has always been falsifiable, and it's even more falsifiable nowadays. But in some cases, it's a nice convenience, and back in the 80s, it was a bit more trustworthy. So, nice feature, but how does the data get down to the device? If the phone's ringing and it's not off hook, then where are they putting the information? Well, I could tell you, or I could just show you. Let's call line 1. Okay, I hope that was audible. That was a burst of modem noises, basically. When you make a call to somebody who has caller ID service, in between the first and second rings is a short burst of FSK data. That's frequency shift key. It's a fancy way of saying that there's two different frequencies, one for 0, one for 1. It's the same thing that was used by the 300 baud modems back at the dawn of computer telephony. And it's used for a few other things even nowadays, but it's a very basic way to send digital signals over an analog line, and that's how it works. Your caller ID box just has a constantly listening decoder in there, and when it sees those tones come down the line, it just decodes them and spits them out on the screen, and that's that. And again, normally you'd never be able to hear that, but because we've got this gadget, you can. So right away, there's a couple of weird things that you could diagnose using one of these. There's better ways to do both of these, but suppose somebody says that their phone isn't ringing. You can call it and you hear ring back, but the phone isn't ringing. Well, if you clip onto their line, put it in monitor mode and hit the button, if you hear the noise, then, well, you know it's probably their phone at fault. Also, if they're saying they're not getting caller ID, well, if you hear that little burst of noise, then it's probably their caller ID box at fault. So 2 more quick and easy diagnostics. There aren't a whole lot of other features on this one. That's mute, that's redial, that's flash. Man, I don't want to talk about hook flashing right now. Flash is useful for sending special commands to the phone company, I'll put it that way. There's a speakerphone, which sadly only works when you're on an actual call, so I can't use it to amplify the ringing signal. And then it does both touch tone and pulse dialing, which is an interesting topic, particularly because of the next device that we have here. This one sets itself apart from the others in a pretty obvious way. It's a rotary phone. I haven't talked about rotary phones much yet, so let's do that. So back in the early days of direct dialing, you know, the earliest phones, you would pick up the handset and then an operator would have to connect your call. But once they introduced the ability for people to dial their own calls, the dial in question was, of course, the rotary dial. And the way that that works is both clever and like infuriatingly oversimplified. I kind of hate it. So in the early days, the only piece of information that was communicated from your phone to the phone company was, are you on hook or not? As we just discussed, that's a very important piece of information. So when they introduced the ability for consumers to dial numbers, they just leveraged that ability. So if we go off hook here and then we dial a number, hopefully that comes through on the task end. You should hear a pulsing noise. And what that's doing is it's literally, it's doing the same thing as if you were to tap the hook switch like that. It's just hanging up the line and then picking it up very rapidly. And I just realized I put away my 2500 set, but I need that to demonstrate this because the hook switch on this one is really sticky. It doesn't go off hook very quickly. So I need to clean that up. But if we plug this guy in, I can show you an old parlor trick that the kids used to do. I'm the kids. Don't know if anybody else ever did this but me. All right, we're in line 2. We want to call line 1. The number is 101. So 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1. Okay, this is like the 3rd or 4th time I've tried to demo this and it has not worked. So apparently this is the one thing that my TLS-5 does not get right. Let me explain. All right, I'm gonna dial 101. And just like that.
It rings. once we go off hook, we have a phone call, right?
But in the olden days, even when I was growing up in the 90s, you could do the thing I was doing here. When you dial a 0 on here, it's basically tapping the hook switch 10 times. And when you dial a 1, it's just tapping it 1 time, and so on. And so if you wanted to impress a friend who was easily impressed, you just dial their home phone number that way. And it's very tedious looking, but when you nail it, it looks like magic. But apparently the phone lines I had growing up, and the ones simulated by these ATAs, and every other piece of equipment that I can think of that I've used that supported pulse dialing, this thing apparently wants the pulses to be faster, because these phones and my electronic phones that have a pulse dialing option, they all work, but I cannot get the hook switch trick to work, which is really kind of a bummer. It used to be one of my favorite things to do back in the day. I'll have to read the manual and see if there's any details in there about like the interdigit timeout or something like that. I'm really surprised that doesn't work. But I mean, it shouldn't, because there's no phone in existence that would pulse as slowly as I'm doing it, or as inconsistently. These guys have clockwork mechanisms behind their dials that ensure that they always pulse at the same rate. There's just a little switch in there that's going like this as the dial goes around. And as long as they're regulated closely enough, and these ones are both in pretty good shape, so they are, then they should always give basically the same cadence. And I don't know what that cadence is, and I'm no good at replicating it with my finger, I guess. But anyway, so this is how phones were dialed up through the mid-60s. I think they started introducing touchtone in 63, 65, something like that. But the reason that you end up with really late devices from like the mid-90s that have the option to do pulse dialing is because for a really long time, touchtones were not universal. For the first like 10, 15 years, they were actually technically an add-on service that had an extra fee on your bill. And so there were people with existing lines who chose not to upgrade. And there were places where they didn't upgrade the equipment for a very long time. Like in rural areas, they didn't get touchtones, I want to say, as late as like the early 90s. And some people just never bothered switching over. And all that means that by the end of the 60s, it was by no means on its way out yet. And that's why we've got devices like this. This is a lineman set that has no touchtone capability, even though I'm pretty positive this came out in the late 60s. I'm basing that largely on the embossing on the base here. This is made by Northern Telecom, or Nortel. They've been a major player in telephony for eons. I think they're still around. I think they got acquired by Avaya or something like that. But their husk is still wandering the earth. And for a long time, they were a big name in telco gear. They made a very popular line of central office switches that was around for decades. But since they're Canadian, I believe that means that this little embossed number down here, it says RD 1967. I believe that's like a trademark or copyright date. And the RD stands for Registered Design, which I guess is the Canadian name for a design patent. And sure enough, I looked it up and I managed to find, I think it's RD 29115 is a design for a telephone handset that looks just like this. And I think that this is actually a consumer telephone handset that they just modified to become a lineman set. So this is from at least 1967 and possibly later. Now, of course, you could already peg it as mid-60s to early 70s by the color scheme. Avocado green, baby, never fails. But also by the state of the plastics. Plastics were pretty immature back then. We had some good ones. They had ABS was figured out, etc. But these things up here are in pretty sad condition. Once upon a time, those were bumpers to keep this thing from flopping back and forth super bad. This used to come up in the front here to limit its outward swing, I think. And obviously that's rotted away completely and the plastic has just turned to hell. I was thinking at first that might be natural latex, but I don't think it is. Based on pictures I've seen on eBay, I'm pretty sure that's something like ABS that's just oxidized and been ultravioleted to hell over the years. If this was much later, I think those would have been some sort of early synthetic rubber, and by now it either would have turned to goop or would be in perfect like new shape. Now, going back to the rotary part, yes, this thing has a rotary dial, and of course that made sense, even if touchtone was around at the time. Well, in the 60s and 70s, I don't know that they could have made the devices we got later that could switch between touch tones and pulse dialing. I don't know if they really could have done that in a single device back then. And obviously you had to have rotary dials on your butt set because a lot of lines didn't support touch tone at all. And besides, you were probably testing rotary dialing. So obviously this needed to be a thing. And it always had been, except the early ones were a hell of a lot bigger and uglier. They looked like this. You'll notice the dial on there is, well, I think it's literally the same mechanism that you've got on this guy. It's a lot bigger than this thing. Like if we look at these side by side, that's a much bigger dial. This is interesting because the process of shrinking the telephone dial actually required quite a bit of ingenuity. You'll notice on this one that there's this gap here, and that's necessary because you need somewhere to pull, even if you're dialing a 1. But on this guy, there is no gap. So how does that work? Well, the stop moves. And it's probably immediately intuitively obvious why that works, but it's interesting to think about. They needed the gap to be there so that you could dial a 1, but they couldn't make the holes smaller to introduce that gap because they need to be the size of a human finger. This is a problem in industrial design. You can make electronics smaller, but the human hand just keeps staying the same damn size. It probably really frustrates smartphone designers, but that's another subject. So they had no way to put more space in the dial, but what they could do is allow the stop to move, which basically allows the dial to rotate more than 360 degrees, which reintroduces the gap effectively. It either makes intuitive sense to you or not. It took me a while to get it geometrically in my head, but it's a very clever thing. And this, I think, was initially invented by AT&T for the trimline phone, and then presumably got put into the lineman sets right after that. They certainly weren't going to develop it for the lineman, I think. But anyway, that's all my butt sets, except for one. And that one, that's a complicated subject. Oh, you know what? Before I do that, I mentioned earlier that phones like this have mechanical bells in them for the ringer. And it's a pain in the ass to take those apart to show you that, but I've got this guy here and he's not a pain in the ass. So I'll just take a moment and do this because it's a neat illustration of a couple things. Well, there's one of them already. It really is just a physical bell. It's one of my favorite things about old phones, just when you're moving them around, and especially if you hang one up angrily, you get that. All right, anyway, there it is. That's exactly the same thing that you'd find in any old telephone set. It's literally just an electric bell. Let's plug this guy in and we'll ring him. All right, this might be loud, but this might be kind of hard to see what's going on there, but this solenoid here, this coil, uses an electromagnetic field to pull the clapper towards one bell, and then the spring pulls it back against the other. Now, this is actually set to the quiet setting. There's this little dial back here, which lets you make the ringer louder. And I'm not 100% sure how that works because you can see when you rotate it, there's an eccentric mechanism that brings this bell closer to or further away from the clapper. And that's certainly some of it, but I think there might also be some sort of muting mechanism inside that actually makes this bell resonate less. I can't quite tell. But as for why we have a denuded ringer here, I don't know that I'm 100% sure about this. This is a Radio Shack extension ringer. And from what I can tell, the idea is if you wanted to be able to hear if a call was coming in, but you didn't actually want to put a phone somewhere, like outside or in the garage or something, you could hang this thing up and plug it in, and it's just the ringer portion of a phone. Now, why would you do this instead of just putting a phone there? Well, one reason I can think of is it's not a good place for a phone. Maybe it's outside. They did make an all-weather version of this. Or maybe phones were just too expensive still, and this was cheaper because it was missing 95% of the circuitry. I'm not 100% sure. You can actually plug a phone in through it, and the phone will function, but it doesn't ring. And I don't know if mine is defective or if that's intended behavior. I suspect it is because while you could plug multiple phones into a single phone line, each one added a certain amount of load to the line called, I think it's ringer equivalency is the number. And past a certain point, the line wouldn't ring anymore. And at some point, the phone company would get mad at you and turn off your service if you didn't unplug some phones. So if you already have a ringer, then you don't want the phone you're plugging in through it to also ring and put more load on the line unnecessarily. That's my guess, but I'm not 100% sure about it. Anyway, here's the last butt set, and boy howdy, this requires a lot of talking because I can't actually do anything with it. So this here, and some people already are gasping, realizing what this thing is. This is an ISDN butt set, and ISDN is such a topic. Back in the mid 80s, I want to say, ISDN was this concept that all the telcos were working together on that was meant to replace the existing nearly century-old phone network with one that was new and shiny and based on all digital technology. Because internally it already was. By the mid-80s, they had replaced most of the core phone network, I believe, with computer-controlled digital switches, or at least they were very much on their way to doing that. By the mid-90s, it had definitely happened. So the idea was, why keep running analog service out to people's homes and businesses? What's the point? If it's digital anyway, wouldn't it be better to just do digital everywhere? And it absolutely would have been. Unfortunately, for reasons, it didn't happen. Here, that is. In other places, it absolutely did happen. I've heard that Germany got ISDN everywhere, and to some extent Japan and some other places, but ISDN never became the thing that it should have been, and it's quite a shame. It might have kept phones relevant longer. I don't know. Now, I could get deep into the details on what makes ISDN interesting from an infrastructure and design standpoint, but I'm not going to. Instead, from a consumer point of view, it was cool because the same two wires that had carried an analog phone line to your house could now carry an ISDN BRI, or basic rate interface, and that would give you not just one, but two digital phone lines. Now, point of fact, point of order, I don't know that the two lines were guaranteed. I've always heard about this advantage, but it's a technical one. Like ISDN allowed you to put two calls over one line, but how did they sell it? Did they come to people and say, hey, your existing phone service that's like $50 a month, we'll upgrade it to digital, and for just $50 a month, you'll get one phone line. We're going to bring you one that could deliver two, but if you want the second one, you're going to have to pay for it. I really strongly suspect that's what it is. And that probably, if that is true, contributed to ISDN never catching on here. I'm sure somebody in the comments is going to tell me whether that happened or not. I have never actually been told exactly what happened to kill ISDN. At any rate, though, if you got that capability, it was fantastic because, well, you had two phone lines, but you didn't have to have a bunch of extra wiring put in. You could just have all your phones replaced with digital phones. They all just plugged into the loop going around the house like they did before, except now any phone could access two lines. And if you wanted four, then you only needed one more pair of wires brought from the phone company. And this was, of course, even better for businesses, but we'll get to that. Now, another feature was data support. ISDN stood for Integrated Services Digital Network, I believe, and part of the integrated was that it had native support for computer data. Not that people didn't have modems in the mid to late 80s, but modems were always janky. The phone company never really wanted people to be using phone lines for data. They actually had other services for that if you were wealthy enough to afford them. You could get leased lines and whatnot that were much better for the purpose. Well, in the process of upgrading from analog to digital, the phone lines would have become a lot better at this. The fastest modems ever made were 56 kilobits per second, and that only became possible by the late 90s, and it was not reliable. A lot of 56K subscribers never got faster than 33.6. ISDN would have delivered 64 kilobits per phone channel all day long forever. It was guaranteed speed, and if you did get two lines, you could bond those to get 128 kilobits per second. And this wasn't mythical. This was a thing that actually happened. This here is a Courier iModem, and it is incredibly heavy. This is like a good 8 to 10 pounds. And this guy can act both as an analog modem in a pinch, and you can plug it into an ISDN line, and you can just bond the two channels together, assuming that your ISP supported it, or whoever you were calling supported it. Because that's the thing, you could just call to another subscriber with ISDN and get a 128 kilobit link directly to their computer. So this was a really cool idea, and it actually happened. It actually got deployed. People really had it. If you install Real Player, when it asks what speed your internet connection is, there's an option there for ISDN. And I knew people who actually had this. It was a real thing, but for complicated reasons, the majority of people never got it. And then it got superseded by DSL, and everyone pretty much forgot about it. But it was very cool, especially because you could have had it in like 1989 or some stupidly early number like that. Oh, and just one thing I should point out before I set that down. This is still a dial-up modem. ISDN still used phone numbers, and even if you dialed up to an ISP that had ISDN access and used both channels like that, you were just making a call to two different phone numbers. The difference is just that it was all data. It was all binary. It wasn't screaming analog tones down a line and hoping they arrived intact at the other end. So in that sense, it's actually kind of better than DSL, but what can you do? So I would love to do videos about ISDN. The problem is that as an American, it is incredibly difficult to learn anything about it or to get any of the equipment that would have been relevant to consumers. For business stuff, I can do ISDN all day long. I used to, it was my job. I mentioned this earlier, the Adtran here, which I'm very used to operating, has two ISDN PRI ports on the back. I mentioned that the thing you get delivered to your house if you were a consumer was a basic rate interface, or BRI, that gives you two audio channels, but PRIs, which ran over two pairs of wire instead of one, gave you 23 audio channels. A bit non-linear. Never been clear on the difference there. I think PRI maybe couldn't run as far, or it cost a lot more to implement. I'm not sure which. In any case, though, I worked with lots of businesses that used PRIs. They were, I would say, nearly universal for any medium to large business by the end of the 90s. They were pretty much everywhere. And I worked with some companies that had 3 or 4 or 6, which is several hundred concurrent calls at once. And so since these guys only have 2 PRI ports on them, I would sometimes have to deploy 2 or 3 of these things and bond them all together. It was a lot of fun. And I can still configure these things in my sleep pretty much. The problem is that PRI and BRI are basically 2 completely different technologies. Under the hood, they work the same, but it's in the same sense that wired Ethernet and Wi-Fi are both sending Ethernet frames, but you can't really easily plug them together without some sort of device that's designed to convert between those formats. And those must exist, but boy howdy are they rare. I have never seen a PRI to BRI converter. So while I do have a little bit of consumer ISDN gear, such as this buttset, I don't have anything to plug it into, and I have no idea where to begin finding anything like that. So consequently, I can't even power up this buttset. I don't even know if it works, and I certainly can't plug it into anything and actually test it. And that's a bummer. I need to find an ISDN expert who can actually help me figure this out, but that's not going to be today. So for the moment, all I can do is tell you about the outside of it and what I think it does. I mean, we can probably assume that it's a phone, right? ISDN phones were a lot more sophisticated than normal ones, so this is probably just one of those in an unusual form factor, but I'm sure it also has some secret sauce, the ability to access tests and settings and diagnostics that a normal consumer wouldn't have. And things like bit error rate testing, which is used for checking whether a digital line is actually clean or not. I think I saw that in the manual somewhere. But other than that, I don't actually know how it works. Do you just plug it in and make a call, or do you have to plug it in and do a bunch of configuration, or no idea. Looking at the outside here, there's a few interesting things going on. First, you'll notice there are 2 different cables on here. One of them has a RJ11 on it. So that's a 2-wire connector. You can see there's just red and green in there, just like a normal phone cord. And then this one has RJ45, the 8-position connector that we now use for Ethernet, which was also used for PRI, as you saw on the Adtran. But, and this is a recurring theme with ISDN, it also got used in the consumer deployment of BRI. Are you keeping up so far? This shit gets really convoluted, and I've always wondered if it's part of the reason that ISDN never took off. It's incredibly confusing. Nothing is simple. Okay, so the line that comes from the telephone company central office to your house is called a U loop, and that uses just 2 wires, just like a normal phone line. When it reaches your house, it plugs into a box called an NT1, I believe, which I think is a network terminator, something like that, and that converts it into a completely different format called S/T. That uses 4 wires instead of 2. That's what loops around in your house and all your phones plug into it. Why are there 2 different interfaces? Well, there's actually 4, but we'll get to that. I believe that the U loop is not ideal for connecting to multiple sets. I think it's just point to point. And the S/T loop is not good for going long distances. So they convert it at the handoff at your house to the one that works better inside the house for multiple drops. Okay, I guess that makes sense. Why is it called S/T? Well, boy, this boils my brain. Because in the design of ISDN, they also predicted that people would have PBXs, not just at businesses as they are today, but also in normal consumer homes. And in fact, in the places where ISDN became popular, this did happen. In Germany in particular, they had a whole shitload of individual scale PBXs that could be used for call routing and special features just inside your house. So what would happen is the U line comes to the outside of your house, the box, the NT1, turns it into an S/T, but from the perspective of the ISDN drafters, if that loop then goes around your house and connects directly to the phones, then that is an S loop, I believe. But if it goes to a PBX, that's considered a T loop, and then the phones plug into the back of the PBX over S interfaces. They're the same. The S and the T are the exact same thing. But depending on where you are in the theoretical diagram, they want to call it S or T, but there's no actual difference in a technical sense. So they're forced to constantly call it S/T throughout all the documentation, even though this distinction it doesn't matter. There's no reason to care about this unless you are a network architect. It's ridiculous. And then, you remember how I was talking about voice over IP ATAs earlier? They would let you plug in a conventional analog telephone to your voice over IP service. Well, those existed for ISDN as well. Here we go. This is an ISDN TA. It's the exact same concept, except it's just this, this dumb black box with no interface whatsoever. You plug your ISDN S loop in here, and then you plug in your analog phone here, and the ISDN drafters refer to this as an R interface. Nobody else in the universe would ever call it that. But technically, according to the diagram, as the line comes into your house and splits out to all your devices, it goes from U to S to T, and then also from S to R. Ugh. Sometimes I think this is why ISDN failed. It's not because of the technical aspects. It's not because people didn't want it. It's not because it cost too much. It's just because it was too complicated. So as a result, this buttset has to have both. We've got this guy for the U interface, and then we've got this for the S/T interface. Look at this hideous mess. And the book for this says to never unplug either of these. Just leave them plugged in the whole time this thing exists, and it's really hard to unplug them too. This one doesn't even have an exposed tab, and that one, the tab's buried all the way in there. So this is how they want you to do it. They want this thing hanging off your belt at all times with all this crap dangling off the back. Geniuses. I mean, I'm blaming the people at Trend Communications, makers of the Aurora Plus, but I mean, what else should they have done? Because if they didn't do that, then you'd always be short one or the other. Now, a question I have is what this is about. My guess is that you could put a pair of clip leads on here just like you can on a normal analog set, and so they provide these banana plugs so you could switch between the RJ11 adapter and the clip leads, but the manual doesn't say anything about it, so well, I don't know. Oh, and if you want to get even more upset at all of this, let's just check out the screen here, because we've got options for AT&T, NI, and Nortel. Remember how I said that ISDN is never simple? There's never one answer to anything? Yeah, so when it was first introduced, nobody agreed on a standard protocol. So both AT&T and Northern Telecom developed incompatible switches, which is weird because I'm pretty sure they all had to talk to each other anyway, and ISDN was supposed to be an international standard right from the get-go, so how this happened, I don't know. So consequently, every single piece of equipment designed for ISDN had to be designed to accommodate both of these formats. But it's okay. They fixed it by introducing National ISDN, or NI, which everybody agreed to use. Do we see how this fixed it? Do we see how you no longer needed to support a whole bunch of different formats because they introduced this one that fixed it all? Yeah. It just meant that now you had 3 options and you still had to ask every single time. And sure enough, every time I set up an ad tran for a customer, I had to get them to tell me which version of the protocol their PBX was using. And would you like to know how many of them knew the answer to that? None. None of them did. Even the PBX techs who've been working on these things for years never knew the answer to this. So in practice, you just plugged it in and then tried each protocol and hoped that the line came up. Boy, I just can't figure out why ISDN didn't catch on. I'm being sarcastic here. That's not the reason at all, but boy, sometimes I'm glad it didn't. But anyway, that's all I have to say about this thing, unfortunately, since, like I said, I can't make it go. I did learn from the manual, though, that apparently it was also capable of being an analog test set, so you didn't have to carry one of these and one of these, and that's sort of a saving grace. But man, I wonder how much this thing cost. I wouldn't be surprised if it was a cool $1,000 when it was new. What else is troubling me? How else can I waste your time before this day is over? Patch panels. This is sort of a minor thing. I don't know, sort of background radiation of this industry that I've always found fascinating. This here is a patch panel. It's actually, specifically, it's called a 66 block. And it's not just a 66 block. To be clear, the front half here is a 66 block, and then this is an add-on. This is some specialized version that some company made. So as I'm talking here, just ignore the badonkadonk and just pay attention to the front. There we go. So imagine you run like a medium-sized office building with like 200 offices, okay? And each one is a different tenant, and each one has 2 phone lines. So you've got 400 independent phone lines coming into your office building. Well, that means that you literally have 800 wires coming from the phone company. And at that point, if they're putting in a trunk that big, they're probably actually gonna put in an even bigger one. Reason being, when you go to install that much cable to a building, you're gonna bury it. And eventually that wire is gonna corrode, it's gonna break down, it's gonna get broken due to frost heaving and semi-trucks driving over the road, stuff like that. Occasionally, wires will fail. Well, when you have 800 of them buried, you don't want to go and dig up that whole cable just because one failed. And you certainly don't want to go out and trench and bury a new 1-pair cable just because one person's phone stopped working. So in practice, they're probably going to bury more than the number of wires you need. And this means that on day one, when you're setting up this whole office, all the wires come in from the phone company, and the first one goes to office 1, and the second one goes to office 1, and the third one goes to office 2, and so on. It's just a one-to-one relationship across the board. And then 2 years down the line, somebody's line fails due to corrosion, water ingress or whatever. The phone company says, okay, no problem. We'll move their service to pair 401. Well, now you need to go get those 2 wires and replace the first 2 wires. Well, if all these wires came together in the basement of your building and were like crimped together or soldered, God forbid, then this process sucks. Because first, in order to make sure you have the right office, you're going to need to cut the leads. And if you're wrong, then you just took somebody out of service, and it's going to take you some time to get some crimps and put the wires. And in the process, you're cutting some of the wire off. And it's even worse if you're dealing with solder, right? So not really in the question. And on top of that, sometimes you need to just disconnect an office temporarily. Maybe they didn't pay their phone bill, or they've moved out and you want to make sure that nobody can go in there and use their line, or you need to disconnect it for diagnostics. They're saying their phones don't work. You need to see whether they work coming in from the telco. Maybe it's an internal wiring issue. For all these reasons and more, you don't want to just connect all your wires straight together. You want to use a patch panel, which allows you to easily move them around on the fly. So enter the 66 block. This design goes back to, I think I read 1962. It's a very simple idea. Each one of these sets of contacts is connected in a pair. So these are connected to each other, and these are connected, but they're not connected vertically, and they're not connected down the middle. So the idea is that all your lines from the phone company come in on this side, and all your offices come in on this side, and they attach to these outer contacts, but then none of them are connected across until you install what are called bridge clips, which I've somehow lost all of mine, but they're just little sheet metal tabs that fit onto the center pair of contacts and just connect them across. Now, hypothetically, you could do fancy rewiring inside one of these blocks. Like you attach all your incoming here and your outgoing there, and then you could attach wires between rows inside here. But I've never seen anybody do that. And as far as I know, it is not a thing that is smiled upon. So I don't think that's what you're ever supposed to do, which is odd. It kind of makes me wonder, why the inner contacts can have wires attached to them. I've never seen anybody do it. If anybody knows the answer to that, let me know. I've always been curious. But anyway, let me show you how this process works. It's actually pretty neat. I've got some Cat 5 cable here, or is it Cat 6? This is Cat 6 cable, but like I said earlier, it's basically the same as the wire that the phone company uses. So obviously, if you're connecting dozens or hundreds or thousands of wires, you don't want to have to strip each individual one and then screw it up, clip off a little bit of wire, go, shit, now I gotta strip it back even further, and I clip off the other one, strip that again, and eventually you're running out of wire and all your wires are different lengths. Horrible. Hate that. But on top of that, you just don't have time. It takes upwards of 5 seconds per wire. You add that up times 1,000, you're spending a whole day just stripping wires. It's out of the question. And it's even worse if you work for the phone company and you're terminating hundreds of thousands of wires, which happens not infrequently, particularly after disasters. Now, I think the 66 block actually introduced the solution to this, which went on to become a universal thing. It's used all over the place. These are insulation displacing connectors. So you install these wires without ever stripping them. Let me show you how that works. I've got a punch down tool here. Here it is. You pretty much need one of these to work with a 66 block. It is virtually impossible to get the wires attached without one. It is a very specialized little instrument. It's got this steel tip on here that's hollow, and it has a cutting blade on one edge. Probably already guess what this is all about, but I'm just going to take a couple of these wires here, and I'm going to bend them over. I'm not very good with this. I never had to do this as my job. It was always technicians on a phone doing it. And we slip these into these little plastic fingers here. I'm going to push that down between the teeth on this contact. You can see the little hammer and anvil layout there, and the wire is actually pinched between those just a little bit. We take our punch down tool, put it on here, and press. That was the punch part. So what that's doing is it's forcing the wire down between those metal teeth, and those metal teeth are actually sharp on the inside. So as it slides down, the teeth cut through the insulation and dig into the copper of the wire. Now, this is critical because if you just had the copper laying on top of a contact, not soldered or anything like that, then you could get oxidation between the surfaces. But from what I understand, and this could be apocryphal, I was just told this a very long time ago, because the blades actually cut into the copper, it never gets exposed to air. So you just have a metal-to-metal interface that should be perfectly clean and unoxidized virtually forever, right? If things don't jostle too much. It works well enough. And the purpose of the cutting blade here is I didn't really get the wire perfectly on there. I didn't get it to exactly the right length, but the blade actually snipped off the excess wire. It's still kind of dangling in there. Is that going to come out? Oh, you know what? It's because I actually got it partway into the next contact. This is, in fact, something you can screw up. It is not foolproof, but boy howdy, is it a hell of a lot easier than soldering everything. Because the thing is, that only took me like 2 seconds to do. And once you get good at it, you can terminate these things really, really quick. Because just like that, I now have 2 wires very firmly attached to these 2 contacts. You can punch down hundreds of wires in an hour if you're good at it. And if it doesn't take, if you don't quite get it on there, generally speaking, the solution is just to put the tool on there and hit it again. And worst case, if you need to redo it, you just rip it out and do it again. It's no big deal. IDC connectors are a fantastic idea, and they went on to get used all over the place. For instance, in ribbon cables, if you don't know, the connectors on ribbon cables are also referred to as IDC. And inside here, they actually have a whole shitload of little tiny sharp metal teeth. And you take one of these ribbon cables, you lay it down on one of these connectors, and then you just squish it with a special tool, and all those teeth cut through the insulation into the wire, and you just terminated 50 wires in less than a second. Absolutely genius. Lots of other applications, including one that you may actually have encountered yourself if you work in IT. You might own one of these tools. This thing has 2 different sets of heads. This is the Type 66 head. It has a cutting and a non-cutting side. I don't know exactly why you would want the non-cutting side. Wouldn't you always want that? Somebody out there maybe knows what the secret is there. But in the tail here, if we rotate this guy, it also has this head, which as you can see is completely different. And this is for type 110 punch down blocks. Now, I don't know exactly what 110 blocks are for. This is another thing I hope somebody will tell me. I Googled it. And all the answers I found sucked. They were all obviously just like generated or copy pasted from somewhere. Nobody seemed to have a hard answer. I know they're newer than the 66 block. I know they're higher density and they have better bandwidth specs. And I think they can be used for Ethernet, at least early like 10 megabit Ethernet. But I don't think they're for that. I don't think that's what it was intended to do. Just people started doing it and it sort of caught on. And they're actually still used for that in a sense to this day. If you work in IT, you've probably seen a keystone jack before. If not, this is what it is. You get these wall plates that have multiple cutouts in them, and you can put whatever you want in the cutouts. It's a standard form factor for, well, in this case, RJ45, but you can also get RJ11 for telephony. You can get RCA jacks, F connectors for like antenna connections. I think I've seen HDMI in this form factor, though it doesn't work very well. And you install these by just clicking them into place. So they're real convenient because they allow you to install one network jack in an office and then later expand to more, or to just replace a network jack when it goes bad very easily. So these are great, but the jacks that you usually use with them are these guys. And that is a very small version of a type 110 punch-down panel. It still uses the insulation displacement principle, but the plastic helps guide the wires in between the jaws. So it's a lot easier to do this without being very good at it. Once again, I'm gonna bend these, and we just lay them down in the slots, and just like that, they're already positioned correctly. Use my fingernail, push that down in there a little bit. I don't know what the right way to do that is, but that's how I do it. Then we just take this guy, make sure the cutting blade is on the right side. Otherwise, you'll cut the wire off as it goes into the cable and it'll just fall out of the connector. I've done that enough times. We just put that on there. And yeah, about half the time it doesn't entirely sever the excess wire. Usually though, I can just hit it again. There we go. And now those are terminated. And again, they're in there pretty good, but you can get them out if you need to by just tugging on them. This is a technology that we can probably thank the phone company for. Like, I can believe in a world where this just never got invented because they were the only organization that saw the profit in coming up with an idea like this instead of just, well, let's just pay people less and less money to do more and more work to make up for an inefficient process, which is generally speaking how corporations handle most of their problems, which is why we're in the mess that we're in. Not to say that AT&T et al. Had no faults, right? But they did a lot of good that would not have happened if they had not been a monopoly. Though, now that I say that, I don't know if the 110 patch panel was invented before or after the breakup, but hey, you know, old habits die hard anyway, so who knows. At any rate, though, I think this is a lot of what keeps phone nerds interested in the phone company and their exploits because, yeah, it's sort of like being fascinated by World War II despite the horrible things that happened just because it got us radar and jet engines and that sort of thing that maybe never would have happened otherwise and which offer lots of good to the world. I think AT&T was a bit less evil than most of the participants in World War II, but some people would disagree with me, I suppose. And again, the 66 block is still around to this day. These are still being used. You know, 1962 to now. I'm bad at math. That's a very long time. So I think the development effort was probably worth it. A couple other interesting things about this, though. I mentioned earlier that there was one more feature about the butt sets that I wasn't ready to show you yet. That's because I needed to explain this guy. Let's get the broken Harris. And now let's imagine that we're out working on a junction box, a B box. And there's thousands of consumer lines coming into it, and we need to get these guys onto a pair of those guys. Now, just look at what's involved here. Even without the wires present, you try to clip on like that. Oh, that sucks. You can see it can easily just bend down and short out like that. You're not supposed to do that. The reason these clips are so strangely shaped is because, are you getting it? The jaws are actually meant to slip over one of these 66 block terminals, and it actually locks in there rigidly. Like, yeah, there's some wiggle, but you're not likely to bump into any other contacts. And the reason that these have the angle at the end is because you can then slip this one over the contact right above it, and they bend away from each other instead of towards each other. And that is not likely to short out against anything, nor is it likely to slip off as it would if you attached it the other way. These are just brilliant. They're just brilliant. And I didn't know this until yesterday. I had looked up the lineman clips many times before, but nobody would concisely explain on the internet all the different ways to use them. And so I actually never found out until I stumbled across a YouTube video yesterday from somebody showing how to use one of these things. It was shot incredibly poorly, much worse than any of the other videos about butt sets on YouTube that I could find, but was just jam-packed with knowledge. I probably don't need to sell you on the value of YouTube as a concept. I mean, you're here, right? But still, it never stops blowing my mind, even though it should be incredibly obvious. The democratization of access to video as a medium has enabled an enormous number of people who can show you a thing, but can't necessarily write about that thing, and don't necessarily know how to get that writing in front of anybody, to finally share information that otherwise is just locked up inside their heads unless you know that individual and can go ask them, hey, Bob, what's this about? And yeah, that pretty much speaks for itself. I don't need to keep talking about that, but it is just fascinating to me. Anyway, one more thing regarding the backside of the block. Like I said, this is not just a 66 block. This is one of the many, many, many elaborations that are out there. A whole bunch of companies started with this concept and then added things to it to suit various applications. So you can just buy dozens of variants. And here's a thing that used to happen pretty frequently, less nowadays, thank God. People would go out and buy analog PBXs, phone systems that expected to connect directly to normal phone lines. And they would just have a bank of RJ11 jacks on them. So you're supposed to just plug ordinary cables into each of those jacks. So if you have all the wires coming in from the phone company, you don't really want to go through the whole process of punching all those down just to turn them into normal cables, right? It'd be nice if you didn't have to do all that work. Well, you can buy 66 blocks that are pre-wired, as this one is. You can see it's got all this nonsense going on in here. And we've got 12 RJ11s around the outside here. And those are all already hooked up. Although, I think they're wired up with 2 pairs per jack, which must be for some special application. This is probably for connecting extensions to a PBX, like digital phone sets that use usually 1 pair for voice and then another pair for a data channel. Because if you hook this up to just a bunch of lines from the phone company, you'd have 2 lines per jack, which can be good, but is probably not what this was intended for. And that's reinforced by the presence of this guy, variously referred to as an RJ21 or an AMP connector, after Amphenol, the people who I think invented that plug. Now this looks a lot like what you see on the back of a parallel port printer, but I think those are 34 pins. This one is 50, and originally these were introduced back in the, oh boy, 40s, I want to say, for the 1A2 key system, which was this ridiculously baroque sort of proto-PBX. In short, it let you have a whole bunch of multi-line phones in your business with up to 9 line keys on them, and it could show you the status of each line. So it needed a bunch more wires to communicate all that information to the phones. So you'd have phones that looked a lot like this, except that they had this great big gargantuan 50-pin plug on the back of them. Well, at some point, the purpose of that plug changed because the 1A2 went away a long time ago. I think they were dead after the 60s. But then at some point later on, you start seeing this plug get used just as a convenient 50-pin plug. 50 pins, that's 25 pairs of wire, which means you can get 25 phone lines through this one connector in a very compact space. I mean, that's the size of 4 regular jacks. So it's much more convenient. What I'm not clear on, though, is whether that was ever like an official standard or if AT&T only ever used this plug for the 1A2, and then decades later, when we started getting PBXs made by other manufacturers, they set on this plug as an existing standard that was just a convenient way to connect a lot of wires at once. Because once people started buying PBXs, they needed a way to connect hundreds of extensions to these units all at once, because you obviously didn't want your PBX to have 500 RJ11s on it. That would be absurd. And so if you look at most PBXs, that's the way they connect to all their extensions. They'll just have 1 or 2 or 16 of these RJ21 plugs, and each one plugs into a patch panel where you then break it out to go to wiring for individual office extensions. Or if even that isn't convenient enough for you, you can buy breakout boxes that just take all 50 pins and just split them out to 25 separate RJ11s. And in fact, if even that's too much pomp and circumstance, suppose you've got the baby brother to this Adtran that I showed you earlier. It also uses an Amphenol connector. And this being the model TA924, that means it supports 24 analog lines. But they made a babby version of it called the TA908, and an even babbier one called the TA904, but we don't talk about that one. And that one only supported 8 lines. Well, this seems like a lot of effort to just hook up 8 lines, right? It is, and so there's a solution for this. And it's called a harmonica, for what should be obvious reasons. This guy just has an amp connector on one side, and then 8 pre-wired RJ11s on the other, and we just slam-a-jamma one into the other, and now you've got the simplest connection possible. You just plug your phones in. You can literally, and I've seen this done, have this in like a lawyer's office sitting up on a shelf and just cables running down from it to people's desks. Oh, so many fun things in the world of phones, assuming you care about phones in the first place. As I said earlier, I never intended to show you every single thing that was on these shelves. Maybe I'll do another one of these grab bag videos some other time and get through the rest of it. But those are most of the points that I wanted to make. These are some of my favorite things as far as phones go. It's one of those things, you never really leave an interest behind, even if you get off the horse to some point. There'll be a day when somebody brings it up and you just start going, oh, well, did you know? And especially if you're somebody like me, I'm pathologically like that. I've had people who met me after seeing my videos actually go, wait, he's just like that all the time? It's not like a persona? No, it's not a persona. I started making the videos because I was already doing this to everybody, and I figured this was a healthier outlet. At any rate, though, that's pretty much every bite-sized piece of phone information I have for you. The other things like the Adtran, the voice over IP stuff, I have so much to say about all of that, but it's all just like deeply involved stuff. I'd love to explain the PBX that I held up briefly, but again, it's just, I would have to tell you what a hunt group is, and even that, it's like 20 minutes of explanation. There's so much front-loading to do for any of it to make sense. I'd have to explain what tip and ring mean. I don't want to do that. So maybe some other time I'll get more into this stuff. I guess it depends what people thought of this video. So if you like this, make sure you let me know, because otherwise I'll assume you hated it, which seems likely anyway, given this is probably like 2.5 hours long. I should probably go and just roll credits. So thank you all for watching. Hope you had a good time. Merry Thanksgiving if you did that.